Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the periodic properties within a group. In our last two lessons, we have studied several such properties, including nuclear charge, atomic radius, ionization potential, and electron affinity. Last lesson, we learned that the electrons in an atom can be removed in succession. However, there are several factors that affect the amount of energy that is required to remove them. We also learned that electron affinity is the amount of energy that is released when an electron is added to an isolated gaseous atom to form a gaseous ion. In today's lesson, we will discuss electronegativity and metallic character as properties of elements that display general trends. Electronegativity is the ability of an atom in a molecule to attract the shared electrons in the chemical bond. American chemist Linus Pauling created the most widely used scale of electronegativity values based on bond strength. His scale ranges from 0.7 to 4.0. Pauling is among the most important scientists in the 20th century. He was one of the first to work in the fields of quantum chemistry and molecular biology. You might also be interested to know that he is one of only two people to have been awarded Nobel Prizes in more than one field. Pauling won both the Nobel Chemistry Prize and the Nobel Peace Prize. Let us learn more about the scale he created. The least electronegative element on the scale is cesium. It has a value of 0.7. The most electronegative element is fluorine, with a value of 4.0. All of the other elements on the periodic table have electronegativity values that fall in between these two extremes. The electronegativity of an atom is related to both its ionization energy and its electron affinity. Atoms that have high ionization energy and high electron affinity also tend to have high electronegativity. This is because the atom has a strong attraction for electrons in a chemical bond. Let us try an activity. Teacher, please divide the students into groups of 3 or 4. Students, in a moment, you will see 3 lists of elements. In your groups, please rearrange each list so that the elements are in order of decreasing electronegativity.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. How did your group do with this activity? Let us go through the answers now. The first list should be ordered as fluorine, chlorine, bromine, and iodine. The second list should be ordered as carbon, silicone, germanium, and lead. The third list should be ordered as beryllium, magnesium, calcium, and barium. Students, perhaps you noticed that each list of elements belongs to a specific group on the periodic table. The elements in the first list are all halogens. The second list contains group 4A elements. All of the elements in the third list are alkaline earth metals. If you have a look at this periodic table, you will also see that the most electronegative elements are at the top of their groups, whereas the most electropositive elements are at the bottom of their groups. Metals are called electropositive elements because they have a tendency to lose electrons and form positive ions. When we move down different groups on the periodic table, the atomic size of the elements gradually increases. As the atomic size increases, it becomes easier for the elements to lose their valence electrons and form positive ions. Therefore, as we move down a group, the metallic characteristics of the elements increase. Students, as you can see here, metals and non-metals are separated on the periodic table by a stair-step diagonal line. The elements that are near this border are known as metalloids. The metals are on the left side of the borderline, and the non-metals are on the right side. Students, the elements that are found within group 5A on the periodic table are arsenic, nitrogen, bismuth, phosphorus, and antimony. Please label each of these elements as a metal, non-metal, or a metalloid.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. I am sure that you had no problem doing this activity. You were correct to say that both nitrogen and phosphorus are non-metals, and that bismuth is the only metal in this group. You were also correct to say that both arsenic and antimony are metalloids. As we learned already, as we move down the group, the metallic character of each element increases. In today's lesson, we learned about general trends in the electronegativity and metallic character of elements down a group of the periodic table. We learned that electronegativity is the ability of an atom in a molecule to attract the shared electrons in the chemical bond. We also learned that metals tend to lose their electrons and form positive ions. This is why they are known as electropositive elements. As we move down any group on the periodic table, the metallic character of elements increases. Therefore, the most electronegative elements on the periodic table are found near the top, while the most electropositive elements are found near the bottom. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.